Hello students, today we are going to go to the next chapter, chapter number 11. It is rotational motion of a rigid body, that is, which involves as a moment of inertia. So this is something to do with rotational motion of a rigid body. When a body rotates, what will happen? And what are the effects you will be keeping in mind when you do calculations, when you do several parameters. Rotational motion. So you need to keep it in mind, it is a rotational motion. Right from the beginning of the chapter till now, we had been always dealing with motion, but it was not a rotational motion, it was dealing with a linear motion. It was always a translatory motion, it was continuously going in a single line. Now it is going in a circle. So I can also relate the same thing with your life. Right from your early age, you have been always going through education in a linear pattern. Linear pattern is you are at home and there is a school. So you come here from home to school, sit in a location and learn what the teacher is saying in a classroom, finish it, come back home. So you go to school, learn, come back. Go back to school, learn and come back. It was a linear pattern where it was always, that's the way it was always the norms. You have to go to school and learn. Learning is always at school. Now, all of a sudden, when the pandemic arrived, you have started having all education back at home itself. You are at home only. Everything is at home. Don't come to school. Sit at home and start learning things. So what happens to school? It is all not happening here. You are at home. Now the rules completely changed. Teachers are not there. And you are given some lessons to learn. You are given some things to continue to move forward in your subjects and your learning. So this linear pattern, it is changing to a pattern which is quite different. I would say it is a totally changed pattern, and every one of you had to really figure out how things will go, and slowly you are trying to come to a conclusion. Yes, it happens only this way. Now school is not going to reopen for some more time. You will sit here at home itself and start learning the same things. So it is a different pattern altogether. So from linear pattern you move down to and a different pattern called online education. Now you are quite settling down in this pattern also. There are difficulties, there are so much of things which is still figuring out how to do it, but there is a way to finally come to a settlement of this. Here also I am taking you from a very important part of learning called linear motion to another new part called rotational motion. You're going to shift your entire thinking from linear motion to a rotational motion. So this whole part of change becomes very difficult. Though you are very much accustomed with linear motion. What is linear motion? So you have three equations of motion. V is equal to u plus at, s is equal to ut plus half at square, and v square minus u square is equal to 2as. All of linear motion formulas. Velocity, acceleration, momentum, force. These are all things related to linear motion. And these all things are very much familiar for us. Now entire thing has to shift to rotational motion now. These three equations of motion will be different for rotational motion. Velocity, acceleration, momentum and force, all things going to be different. You will be shifting completely from one end to another end. Just like you shifted completely from a usual learning method to a online learning method, you are going to shift from linear motion to the rotational motion. So the challenge is it will be difficult. I am telling you before itself, it will be difficult. You just that learning, going to school and learning and coming back and coming only to school and constantly learning here, it was so difficult to change. Now you're quite used to now at this point of time after 6 months. Similarly, we were going to make a whole shift from this linear motion thought process to a rotational motion thought process. Okay, so to start with, to just begin with itself, we will begin with something very important called force. When a body is there, you want to move it in a straight direction, what do you give? Give force. We already know when a body is already standing here, there is having inertia. Inertia is there, and there is a mass which is there. Because of that, the body is unable to move. So if you give a force, the body starts moving from one to another position, and it moves a particular distance. Now similarly, suppose a body is here, this is put in an axis here, maybe you can say it is a kind of a disc or something like that, and it has a radius, and now this body should start rotating. How it can start rotating? What you should do, you need to give a force. Give a force into this body, just give a flick, make a flick, and it starts rotating across this axis with this axis of rotation. Maybe you give a force in this direction, tangentially. Maybe you give a force like this. Any direction you can give. Force across this radius, you give a force, then it starts rotating. When it rotates in this pattern, we call the force created on the radius because of the linear force, that is called torque. We are quite familiar with this word called torque. We have learnt it in the lower classes. In 10th also you have learnt about a turning effect, moment of force called torque. Now we are going to define this clearly about what is torque. The torque means whenever a linear motion is there, you have a force which is to be applied, so the body moves in the linear direction. Similarly, whenever rotational motion should happen, you should give a torque in it. Then only it will move in the rotational part of it. It will constantly go on a rotational motion. So a body has to move from one place to another, you will give force. That is for linear thing. A body has to move in a rotational basis, you need to give torque. But torque and force has some relationship. You can relate to one another. So that's what you're going to see, how it is going to be elaboratedly seen. So we are going to see the topic as moment of force or torque. I'm just drawn a very abnormal picture. It is just a lamina, irregular lamina. Not a square, not a rectangle, but it's just a irregular plane sheet. Now let us make a hole here and put a stick in this one. You put a stick here and the stick penetrates and comes here. This is the stick. Now this lamina, irregular lamina or irregular thing, it is just hanging here. Now you wanted this one to rotate. This can rotate, go around and round. When it goes round and round, it will make a big circle and come back. Sometimes you have played like this. Put a hole in somewhere and keep on rotating. Have you played like this? Yes, you have played. Now we are going to define torque. We are going to define torque. Torque happens only on an axis of rotation. That's very, very clear. You need an axis of rotation. So we have defined the axis of rotation. Now let us imagine there is a point P here, a particle here, at a distance R from the origin here. So from the axis of rotation, this point P is here. This point P is one of a particle. Now this particle, which is a part of a huge lamina, what you do is you give a force. I give a force on this particle. That is, this particle is anyhow the part of a big thing. So I just give a force. I am not giving a force here I'm not giving a force in this periphery, but I'm giving at one of a point where the particle P is there, trying to give a force here. When you give a force here, what will happen? This particle will start moving. When it starts moving, it cannot go straight. It will follow a circular path, because this entire thing is now fixed to a center of axis. It cannot go in this direction of force. Where it will go? It just goes to go around and come back. So there is no other option for this point to go anywhere. It has to just go in a circle. Now when you are giving a force here, right, there is an angle theta in which it has been operated with this radius of the rotation. So there is an angle theta. Now R and F is having an angle between them. You're not giving force in the same direction of R. You're giving a force in that direction different than R. It is a theta angle is there. Okay. Now I will define what torque is. Torque, it is called as tau, is going to be equal to R vector. This is the R. And then this is F. And the sine theta between these two, between R vector and F vector. So torque is going to be equal to R cross F is the actual full sense of the formula for torque. Torque is going to be equal to the radius vector and the force which is you have been applied and the angle between radius vector and this one. Suppose if this is the force here, you can parallelly put the same force over here also, which will be looking as if the force is here. Actually the force is only applied here. This is a thick line. This is just a dotted line. We are trying to match this one so that the angle will be referred here. This angle is referred here. This same angle is referred here as F vector. So when you do this rotational motion, like you give a force in this direction for this radius, the theta value is taken from R to F. Look at this one. Theta value is so important, from R towards F. In that direction of R towards F, then the torque will be in upward direction. The torque will go in the upward direction, because the right hand thumb rule says you hold this one, and if this is the one and you hold it together in your grab this one from R towards F's direction, from R towards F direction, then the direction of the thumb will show the direction of the direction of the torque. I'm again repeating, the direction of torque, how we can define? It is a vector quantity. So R vector cross product of F vector, there is an angle in between. From R to F, if you say, it will be going in the upward direction. From F to R, if it goes, if it is a force is in the opposite direction, it is going to be F to R, then it is going to be downward direction then. So torque is also equal to RF sine theta. Look, you have not written anything, I have just explained it for such a long time. It is quite important. That's the reason I have explained. Draw this diagram, draw this picture with force and P and parallel here, and write down these things. Torque is defined as the force applied on a particle located at a distance r from the axis of rotation, located at a distance r from the axis of rotation, having an angle theta between the radius and the force, then torque is equal to, write down this formula, torque is equal to RF sine theta. RF sine theta. And write the next line. It is also a cross product. Torque vector is going to be equal to R vector cross F vector. And you can write it as RF sine theta is the value. The direction of torque depends on direction of torque depends on the rotational part from r vector towards the force. From r vector towards the force. Then according to right hand thumb rule, torque will be along the upward direction. Okay. So now you can see in the book how it is written here. Now this is another diagram. I took a big lamina, but they have taken a plane and they have given a point P of a distance r, and F is force is given here, and because of this force and r, it rotates. As it rotates, that rotational effect takes place, and this is the torque, which is the final part of the rotational motion because of torque. What is torque? Force into perpendicular distance. Force into distance, r cross F. So Rf sine theta. Similarly here also, the same thing is given here once again. So r vector and force is given here, and there is an angle theta here. The theta is very important. Here also the angle theta is there. Okay, so they are able to define it. So torque vector, it is acting in the upward direction. In the upward direction it will be there. The next line you can write, the SI unit of torque is going to be equal to Newton meter, because it is force is Newton and meter is the distance. The next line, the dimensional formula for torque is given as mL2 t minus 2. Please write down the dimensional formula is mL2 t minus 2. Now moving further down, we find torque is also the way it is called as torque is equal to r of sine theta, and clearly torque due to a force is only due to a transverse component of force. The radial component of force does not contribute to the torque. So torque is actually the transverse part. Transverse part means the push that you give in a linear direction. Because of that only, the force only, because of that force only, torque will also take place. So that's a way in which it has been told the radial part of it is because of torque, and the linear force it is given here. So rectangular component of torque, you need not study this one, it's okay. R cross F, you know it is a cross product, we have already done this one, you need not do that one. We will move forward to the next one called angular momentum. We will go to the next one called angular momentum, right? So I hope you understood about torque. If you are not understood, again we will go back to the torque little more later in another time. If you already understood, it's great. Please read this one. Now we'll go to the next one called angular momentum of a particle. Angular momentum of a particle. We have always seen linear momentum. What is linear momentum? P is going to be equal to mass into velocity. We already know this one. That's what always in our mind. Now what is angular momentum now? Take the similar situation of a big lamina, and there is a point where you have put a hole, and this whole lamina is now hanging over it here. Take a similar point of P at a distance r vector from the axis of rotation. Now what you do is, when you apply a force F, similarly you can apply a momentum also. Let momentum be in this direction, because the force if you apply, that will be equivalent to the momentum of the body also, because mass into velocity also it is there, because you have applied a force. Similarly we can apply, instead of force, you can say the other way is, we have given momentum to this body, linear momentum to this body. So when you give a linear momentum, same rule it applies. There is an angle theta will be there. So this same angle theta, you can make it as a parallel one and make it theta here as the same momentum which is here. Actually this is the place where the point happens, momentum happens, but you can just do a parallel thing here. When it is here, this P point is just a point P vector is the momentum here, it is going in this direction. So you can write it here as the momentum, angular momentum. We call it as J. Angular momentum J is equal to RP sine theta. In other words, J vector is going to be equal to R vector cross P vector. So it is quite clear how this one takes place. We are not talking about a linear momentum, we are talking about angular momentum. So the direction of this one also exactly the same way of torque also it can take place from R vector to P vector. If you just rotate it in a right hand screw rule or right hand thumb rule, J vector will be in the top direction. So can you write this one? Consider point P at a distance R from the axis of rotation. If P vector is a momentum, linear momentum given to the particle, the body rotates. Hence, angular momentum is the product of the distance R vector from the axis of rotation and the linear momentum applied to this body along with the sine theta of the angle between R vector and P vector. So what is sine theta of angle? This is the sine theta of angle here. So what we saw, R, P, product of R vector and P vector and sine theta. The next line, you can write here, J is equal to RP sine theta and then J vector is equal to R cross P vector. Please write this one. Now here write down, J vector is angular momentum. Its direction is given by right hand thumb rule. J vector direction is given by right hand thumb rule. When we traverse from R vector to P vector over an angle theta, then angular momentum J vector is directed in the upward direction. Please write down. I hope you are all writing there. When we traverse the angle between R vector and P vector, then J vector is acting along the upward direction along the axis of rotation. Hope you got the idea about it. So now we got two very important formulas. Torque is going to be equal to R cross F, and similarly angular momentum is going to be equal to R cross P. So these two are the very important formulas that you got it. So similarly here also, look at this one. Momentum, linear momentum is applied here and distance, it starts rotating. So you got here as J vector is equal to R cross P vector, and in other words you can also write it as J vector is going to be equal to RP sine theta. So it's going to be equal to R into P is a perpendicular distance. So that's the way it is. So J is equal to RP, and if you have theta is equal to 0 degrees or theta is equal to 90 degrees, accordingly it will change. Alright. Now we will move little more into distance, velocity and acceleration. The next part is, we always have these things there: distance, velocity and acceleration. What is distance is going to be equal to? Alright, the displacement you can say, that is the distance which is travelled, And what is velocity? It is ds by dt. What is acceleration? It is dv by dt. You already know this one. We are going to change this one from a linear motion to rotational motion. Rotational motion. So you write there as rigid body rotation. The topic should be rigid body rotation. Look at this one. Rigid body rotation. So when it rotates, we already know the way in which it is been given here. Whenever it rotates, this is the linear displacement. What is angular displacement? We call it as theta. What is theta is going to be equal to? What is angular displacement? Write down. Angular displacement. Theta is given here as, it is length of the arc, distance upon radius. We have already seen this one in a circular format. Last time itself we have seen. This is a radius. From here to here, it goes for a distance s. And there is a theta here. From here till the s1. S is the distance, r is 1. S upon r is going to be equal to theta. We already know this one. So what is s is going to be equal to theta into r. R theta. The next line is differentiate. Please write down. Differentiate on both sides. So ds upon dt is going to be equal to r times of d theta upon dt. So ds upon dt is going to be called as a velocity, and r we already know this is a radius. D theta upon dt we already know it is going to be omega. What is omega? This omega is called angular velocity. So we are coming to another important part called v is equal to r omega. Next line. Differentiate on both sides. Again, dv by dt is going to be equal to r into d omega by dt. So what is dv by dt is going to be acceleration. R into d omega by dt is alpha. What is alpha? It is angular acceleration. So A is equal to R alpha. So you get here S is equal to theta times of R, and ds by dt is going to be the value here. Now you are going to have a relationship between linear motion and rotational motion. This is linear motion velocity. What is this one? It is a rotational motion, angular velocity. This linear velocity is angular velocity. This is a linear acceleration, this is angular acceleration. In all of them, you find one common factor called R will come. R will come here. So, linear displacement, linear velocity, linear acceleration. And what is the angular displacement? Theta. What is angular velocity? Is omega. What is angular acceleration? Is alpha. In all of them, when you transfer from linear to angular, you need to multiply it by radius, radius and radius. Distance is equal to r theta. That was here. Distance is going to be equal to r theta. Velocity is going to be equal to r omega. It was right here. Acceleration is going to be equal to r alpha. It is right here. All three. So from linear to the angular. From linear velocity to the angular velocity. From linear acceleration to angular acceleration, you have to multiply by the radius of rotation. So that is very important. So hope you would have got it and clearly understood it. So you need to keep it in very clear mindset of how it changes, and it goes on to the last part here. The next part is moment of inertia. So what is moment of inertia? This is the last topic we'll lead, and then we will finish. Moment of inertia. So again, I'm going to have a big body here like this, and this is a hole which is here, and there's an axis here, and it penetrates down, right? This is the bigger body. So write down the topic here, moment of inertia. It is also called as radius of gyration. G-Y, gyration. So what is moment of inertia? First of all, we'll try to define it. Then you can go to radius of gyration. So what is moment of inertia is, suppose this is a small particle here. We call it as M1, right? And then this is another particle here. We call it as M2. This is another particle M3. This is another particle M4. Here it is another particle M5. So we have here all of them having one by one distance here. R1 distance, R2 distance, R3 distance, R4 distance, R5 distance. These are all different distances here. Okay. Now what happens here is, we need to find out what will happen if this one starts rotating now. Alright. So what is basically moment of inertia we are going to define. So hope you understood the diagram. The understood the diagram is, the whole lamina is there. There is an axis of rotation. Now we are taking different particles and different parts of the lamina with different distances. So write down, consider a body rotating in an axis of rotation. I'm going to write down now. Let M1, M2, M3, M4 and M5 be different particles of masses at a distance of R1, R2, R3, R4 and R5 from the axis of rotation. Okay. Now the important thing is, what is moment of inertia? Now look at this one. When you have a body which is here in a linear part of it, this body is having an inertia. This body doesn't move. There is a mass here. You have to give a force. So the inertia opposes the force. What happens here? The inertia. So the inertia of the body opposes the force. The body doesn't move fast because of inertia. Similarly, the moment of inertia is an opposing force for the rotation of a body. I am again repeating my words. In simple words, straight to understand is, moment of inertia means the unwillingness to rotate, the inability to rotate by itself. It is because of inertia, which is called moment of inertia. Inability to move by itself is because of inertia. There is a linear inertia. Inability to rotate by itself, it is because of moment of inertia. Hope you got that basic idea about it. Okay. So anything cannot rotate. You need to rotate with another force. So we are trying to have different things in different points of thing. So we call it as, the moment of inertia is defined as, write down, the moment of inertia is defined as sum of the product of mass and square of the distance from the axis of rotation. So you again repeat, it is the moment of inertia is defined as the summation of product of two things, mass of the particle and the square of the distance from the axis of rotation. So in other words, moment of inertia of the particles is equal to m1 r1 square, m2 r2 square, m3 r3 square plus m4 r4 square plus m5 r5 square, etc. So many particles are there. You can keep on going for millions of particles all around. So what is the total moment of inertia? I is going to be equal to, it is summation of mi ri square. So if you keep on having so many particles, for totally what is the mass? Total mass is mi, summation means it is going to be equal to capital M. And it is going to be the r square value of this one. So that is called moment of inertia. So moment of inertia is a product of mass and the square of the radius. You can write down the last line. Moment of inertia is the product of mass and the square of radius. Now look at this one. Moment of inertia of a rigid body about a given axis is the sum of products of the masses of the particles by the square of their respective distances from the axis of rotation. That's what you wrote. This is what the final thing is. So m1 r1 square, m2 r2 square, m3 r2 square, summation of mr square. So it's going to be totally is mr square. Okay children, with this I close. It has an SI unit. The SI unit is, please write down, kg meter square, and the dimension is ml square. Fine, I think with this it is okay. Tomorrow we'll continue to do with the next part of moment of inertia. Please read this one. Quite important thing. We didn't do much of the things, but we have just heard what is that. Basics are understood. We'll move forward tomorrow. Thank you.